let's start with our first, call them chalk talk reviews. They are very similar to what we would be doing for on the board in the book notes if we were face to face. So, this one is going to cover chapter 9, section 1. And chapter 9, section 1 is all about why cells are small and if they can, how do cells reproduce? So, why are cells small? We said there are 3 reasons. First one, surface area to volume ratio. If a cell got any bigger than what most cells are, one of the 3 problems becomes that the surface area, the amount of plasma membrane, is going to get bigger as the cell gets bigger, but not as quickly as the volume or the cytoplasm of that cell does. So as cells get bigger, the surface area to volume ratio becomes too low. This number gets bigger, this number gets bigger, but when you divide them, you get a number that is lower after you've got any bigger than that. So the first reason was our geometric reason. The second and third reasons are both related to the amount or the speed of diffusion. So these are really biological issues. The first diffusion issue is the diffusion of raw materials in and waste out. Those work just fine as long as cells are very small. It happens very quickly, but if cells got even just a little bigger, that diffusion would take a lot longer. The other problem we'll call communication. Communication in a cell is the diffusion of info from the nucleus. And we know from previous chapters that information in a cell is nucleic acids, the nucleotides. DNA, in this case, the DNA has to be copied to RNA. That RNA has to make its way out of the cell, find a ribosome, and be transcribed into a protein. So we have a pretty good handle, I think, on why cells need to be small. So now we'll look at the process that cells go through in their lives. This is called the cell cycle. And the cell cycle is, for convenience, divided into 3 parts. So we'll start with a freshly born cell. That cell will begin its life in interphase. From interphase, it will transition into mitosis. And overlapping with, but we'll call it a 3rd section for now, mitosis is the process of cytokinesis. So far in this chapter, we have not looked at the details of mitosis and cytokinesis, but as this is review, I know you know a lot about what goes on in mitosis and cytokinesis. In interphase, we have subsections. First subsection would be G1. Second, S. And the third, G2. Now G1 stands for gap 1. And I've told you to think of it as growth 1 because a lot of what's happening here is normal growth. Cell just arrived from another cell through this whole process. It's got to grow. When it reaches its size limits, it'll start to go about its normal business. If it's a liver cell, it's helping you with the digestive process, helping you get rid of toxins. If it's a muscle cell, it's either helping you move around, or if it's a smooth muscle cell, it's helping things move through your body. Anything that normal cells do, those cells are in G1. When those cells are told to divide, the next thing they go into is S. And in S, they make a copy of all their DNA, make a genome copy. Now they have all the instructions needed for a new cell, plus the instructions for this cell, so they have twice as much DNA. And then finally, if they're going to divide, last minute growth will occur in G2. In order to do all these things, have normal growth, go about their business, they need to be reading and copying the DNA. In S, they are making a DNA copy of the DNA, something that's not normally done. In fact, this S part of interphase is the only time a DNA copy of the DNA is made. But in order to do that, you have to be able to read it. Same is true with last minute growth in G2. So throughout interphase, no matter what part of interphase you're in, the DNA has to be in the form of chromatin. It has to be an opened up, readable form of DNA. That is also going to be true when we get back over here to cytokinesis. In the middle part, where we have mitosis going on, we are going to see that you need chromosomes during that part of the cell cycle. At the end of this whole process, we will have two genetically identical cells to the one we started with. And now both of those cells will start out in G1. They may go on to S and G2, depending on what kind of cell they are and what they are doing. And this process will continue. This is the process that builds organisms. All organisms start out as one cell, and that cell makes genetically identical copies of itself until you get a full organism. Again, this is how we heal. You have a cut, you lose a cell, you replace it using mitosis, if possible. And again, if you are a single-celled organism, this is pretty much the way you make a copy of yourself, how you reproduce. Right,